if I have 3 a squared b to the 4 all to the power of 2, I'm using the indice rule here, which is that a, b, all to the power of m is equal to a to the m, b to the m. So you imply the power that is outside the bracket inside to each of the bases that we have. Using that understanding here would mean I'd apply this power of 2 to each of these parts inside the brackets. So I'd have 3 to the power of 2, a to the power of 2 times 2 is 4, b to the power of 2 times 4 is 8. And you can leave your answer as that. You do not need to evaluate the 3 squared. It is perfectly fine to leave it as 3 squared because sometimes you might need to use this answer later on, and by not simplifying at this point in time, it may actually be beneficial. Another one to try using this understanding would be if I had minus 3a all squared times, and here I'm using the dot notation for times because, as I said before, it is better not to use the multiplication sign. 2a squared b all to the power of 3. So again, I'm using this indice rule that I have here, and so applying the power in first, I get minus 3 all squared, and it's important that I put the brackets around the minus 3 part because sometimes people can get confused. If you square any negative number, the answer will always be positive, and so to make sure that you get that, please put the brackets around it. A squared multiplied by 2 to the power of 3. A to the power of 3 times 2 is 6, and b to the power of 3 times 1, which would be 3. Simplifying further now, I would have that minus 3 squared is 9, a squared is 2, a to the 2, sorry, multiplied by 2 to the power of 3 is 8, a to the power of 6, b to the power of 3. Multiplying my numbers together, 9 times 8 is 72. A squared times a to the 6, you add the indices together, so 2 plus 6 is 8, b 3.